Hi guys. So today we are going to do our last unit. We're going to look at an entirely new type of graphing. Today we're going to look at just kind of how to plot some points and how to convert some points. And then next class we're going to look at the newest graphs and the most interesting graphs you have probably seen all year. So what we're going to look at these next 2 days is what is called polar graphing. So polar graphing, like I said, it's an entirely different type of graphing. We're not even going to use the same type of graph paper that we've used. It has its own different type of graph paper. So polar graphing is different than what we normally do. What we normally do is called rectangular graphing, or the Cartesian coordinate system you might have heard. Rectangular coordinates, what we're used to doing, are in the form of x comma y, and that's what we've done for almost everything. Polar coordinates, though, instead of x comma y, are r comma theta. So your polar graph paper is going to look like these little spider webs almost that you have down there. It's a bunch of little circles over and over and over again. The center of that graph is called the pole. So of those, whenever we graph these, you have an r and a theta. So r is the distance that you move from the pole. So however many rings we move out, that's what r is. Theta is the angle where we're actually going to graph the point. So if r is negative, then we're going to go in the opposite direction. So let me go ahead and graph a couple examples here. All right, so 2 comma pi over 3. That means we're going to go 2 rings away at the angle pi over 3. So the angle's kind of listed here. So here's the angle pi over 3. We're going to move 1, 2 rings away. So that point right there is the point 2 comma pi over 3. All right, 3, 11 pi over 6. We're going to go to the angle 11 pi over 6, and we're going to move out 3 rings. 1, 2, 3. All right, 3, negative pi over 6. Well, negative pi over 6, if you remember from our graphing, that means we go pi over 6 the opposite direction. So we're going to move the opposite direction. Now, if we don't remember that, the other option is we can add 2 pi and get a coterminal angle, which happens to be 11 pi over 6. So whatever way you do it, either you move backwards pi over 6 or you add 2 pi and find that angle, that's where we're going to move. And then again, we're going to move 3 rings out. So those 2 points actually are the exact same. That's just 2 different ways we can write them depending on the angle that we use. All right, let's graph a couple more. So 4 comma 13 pi over 4. Well, again, 13 pi over 4 I don't see. So we're going to find that coterminal angle. We're going to subtract 2 pi. So we're going to subtract 8 pi over 4, which gives us 5 pi over 4. Now, the pi over 4s in this graph paper aren't listed, so I'm going to go ahead and put them on there. They're going to match your unit circle. So 13 pi over 4 is the same as 5 pi over 4. We're going to move 4 rings out. So 1, 2, 3, 4. All right, let's go to negative 3 pi over 2. So this is a negative radius. So what that means, pi over 2 is right here. So if it was positive 3, I would move 1, 2, 3 rings out and plot that point here. Since it's negative, though, I'm going to go 180 degrees in the opposite direction. So I'm going to move 1, 2, 3 rings the opposite direction. So there's actually, again, a different way you could write this point. This would be the same thing as 3 comma 3 pi over 2. So there is more than one way to write all these points that we're going to have. All right, let's go to the next one. 0, 3 pi over 4. So the angle 3 pi over 4 would be over here. But if I'm going 0 rings out, it's just going to be here at the middle. And if you think about it, it doesn't matter what the angle is. If the r is 0, it could be any angle you want. Your point is still going to be plotted in the same place. If r is 0, it's plotted at the pole. All right, so let's look at one of these points that's on our circle. We're actually going to say, like we said, we can write these multiple different ways. Let's come up with some of the different ways we could write this. So I'm going to plot the point 3, negative 3 pi over 4. Well, first of all, let's figure out where negative 3 pi over 4 is. I'm moving backwards 3 pi over 4. So 1 pi over 4 would be 1 quadrant away. 3 pi over 4 is over here. Then I'm going to move 1, 2, 3 rings out. Well, one way we could write this is instead we could write the positive angle. If I start at 0 and go in this direction, figuring out what that angle is. All right, that might be what some of you did to figure out where to graph this. If I do negative 3 pi over 4 plus 2 pi, I get a common denominator and I add them together. It's still 3 rings away, so another way to write this point is 3 comma 5 pi over 4. All right, let's think of another way I could write this point. What if I used a negative r value? If I used a negative r, the angle I would use is the angle that is 180 degrees or pi radians away. Well, that angle is pi over 4. So if I use the angle pi over 4 and a negative radius, that would graph the same point. Well, if I want another point, I can do the same thing with that negative radius, but I could write pi over 4 a different way. I could write the negative angle there. So if I start at 0 and move around this way, I would be going backwards 7 pi over 4. And there's many, many, many more angles that you can use or different ways that you can write it. But this is just a few examples of the different ways we can write these points. So what we're going to do now is we're going to convert between the 2 points, between polar and rectangular and between rectangular and polar. Now you guys are going to see some pretty similar equations that you guys saw in the last unit. So we'll start with polar. Okay, if we have polar, that means we have r comma theta. So if I have r and theta, r is that diagonal distance. It's how far we're moving away from the center, and theta is the angle. In order to get this to be rectangular, I need x and y. Well, if I look at this picture, if I were to try to solve this equation for x, I can use a trig function. The trig function I'd use, this is adjacent and hypotenuse, so I could say that the cosine of theta is equal to adjacent over hypotenuse. Well, if I try and solve for x here, I would get r times cosine theta. If I try and do this for y, very similar. Different trig function, I would use sine. Sine is opposite over hypotenuse. Then I try and solve for r, I end up with, try to solve for y, I end up with r sine theta. So these equations probably look familiar because this is basically what you guys did to get your component form for your vectors. All right, now let's go the opposite way. Let's start with rectangular. So we're starting with x comma y, and we're trying to get to polar. So I know x and I know y. Well, the first thing I need is r. Okay, I'm trying to figure out what r is. Well, if I know x and y, that's a right angle. X squared plus y squared is equal to r squared. So r is the square root of x squared plus y squared. That also might look familiar from the last unit because it's the same equation as magnitude. And guess what? This last one's going to look the same too. Let's say we're trying to find the angle. Well, the tangent of the angle is y over x, which means if I want to find theta, I would do tan inverse y over x. Now, also similar to what we've done in the previous unit. Now, some of these, a lot of these we're going to give you kind of the unit circle values. So the best practice would be to not use a calculator. But if you do happen to use a calculator, if your angle is in quadrant 2 or quadrant 3, then you are going to need to add pi if you're using your calculator. Just like we added 180 when we used the calculator for degrees. Now, if you don't use your calculator and you're just using the unit circle, you'll be okay. All right, so let's go ahead and convert some of these points. So we're going to start with going from polar to rectangular. So I have an r and a theta. I need an x and y. So x is going to be r cosine theta. Y is going to be r sine theta. And like I said, these are unit circle values. So the best thing you can do for practice, especially if you're going into calculus next year, is to actually know these values off the unit circle. So the cosine of pi over 6 would be root 3 over 2. So this would be 6 root 3 over 2 divided by 2, which is 3 root 3. Your other option, if you want to, you could use a calculator. However, notice that this has a pi value in it. If you are using a calculator, check your mode. Your mode should be in radians if that's the case, because pi over 6 is a radian value. All right, so let's do 6 sine pi over 6. Whoops, I'm showing the highlighter. So that's going to be 6 times 1/2, which is 3. So this point would be 3 root 3, comma, 3. So to check our answers, I'm just going to plot these, just for extra practice plotting, but also so you can see it's in the right general area. If I were to plot the point 6 pi over 6, I would go to the angle pi over 6 and move 6 rings out. 1, 2, 3, 4, 5, 6. So that point right there would be 6, 5/6. Well, let's plot the point 3 root 3, 3. So we may not know where 3 root 3 is. If you want, you can do your F to D on the calculator to figure out about what that decimal is. What we also know is 3 root 3 is the square root of 27. Well, we don't know what that is exactly. I know it's in between root 25 and root 36. So it's in between 5 and 6 somewhere. So I'm going to go a little bit past 5. The actual decimal is like 5.2 or 5.1. So this is about 5, 3. And if you look, those 2 points, they're plotted in about the same place. All right, let's look at 2, pi. Okay, 2, pi. So we'll do x equals 2 cosine pi and y equals 2 sine pi. So the cosine of pi is -1, so that's going to be -2, 0. So again, if I want to graph this, I'm going to go to the angle pi and go 2 rings out. If I want to plot the point -2, 0, those points look pretty similar. All right, -4, 3 pi over 4. So x equals -4 cosine 3 pi over 4. Y equals -4 sine 3 pi over 4. Now again, these are unit circle values, okay? 3 pi over 4, cosine of 3 pi over 4 would be -√2/2. So if you don't have a calculator, that's okay. These are unit circle values that you can figure out without a calculator. Now, if you do have a calculator, yes, you can go ahead and use one. But again, it's really good practice to do this without, because that's what you might need to do later on. The sine of 3 pi over 4 is √2/2. Multiply that by -4, and you get a -2√2. So again, I don't really know exactly what that number is. I could use a calculator and do F to D. It's also about the square root of 8, which is going to be in between 2 and 3. So this point here, 2√2, -2√2, is about, it's kind of like an almost 3, -3. So that point's going to be kind of somewhere in there. Not quite in the line, but kind of close. If I plot the point -4, 3 pi over 4, here's the angle 3 pi over 4, but I'm not going to go that direction. It's a -r. I'm going to go backwards 180 degrees, 1, 2, 3, 4. And that is going to be where my point is. And again, it's about the same area. All right, now let's go the opposite direction. Let's go from rectangular to polar. So we need an r and a theta. So r is going to be the square root of x squared. Be careful with those parentheses, which is √2. Theta is going to be tan inverse 1 over -1. So again, this actually is something you could do on the unit circle. All right. If you think about that, tan inverse of -1. Tangent's negative in 2 different places. And because the point -1, 1, let's go ahead and plot the rectangular. -1, 1 would be over here. Okay, that could help you figure out what that angle is. It would be that other quadrant angle. It's going to be somewhere in here. Tangent's 1 where the x and y are the same. Or again, if you plug it into the calculator. Now, if you plug it into the calculator, keep in mind, the x here was negative. This was a quadrant 2 point. So what we would need to do then is we would need to go ahead and add, not 180 because we're in radians, we would have to add pi to our answer. So if I did plug this into a calculator, let me grab one real quick. If I plug this into a calculator, it's going to give me -pi/4. Then if I add pi to that value, it's going to put me in that other quadrant, which is 3 pi/4. So r, theta. So again, if I graph this, I go to the angle 3 pi/4, and I move √2 away. Again, I don't know where √2 is, but I know it's more than 1 and less than 2. So it'll be somewhere about there. If you want to use a calculator to figure it out exactly, you can. All right, let's go to the next one. Let's find our r value. 2 squared plus 2√3 squared. So if I square that, that's going to be 4 plus 2√3 squared, which would be 12. So that's going to be the square root of 16, which is 4. All right, so that's my r squared, or my r value. Then let's find our theta. Tan inverse y over x. So tan inverse of those 2's divide out, tan inverse of √3. that is a unit circle value. That's something you could find on your unit circle. Now, again, keep in mind, if you don't remember, it is possible to do this on your calculator if your mode's in radians, but it is good practice to try it without. And either way, when y divided by x is root 3, that is going to put you at the angle of pi over 3. It does make sense. We should be in the first quadrant because the point 2 to root 3, those are both positive. So if I were to plot that 2 to root 3 in rectangular, if you don't know what 2 times the square root of 3 is, we could plug that in. I can get the decimal. It's about 3, almost 3.5. So 2 comma about 3.5. Then the point r comma theta, 4 comma pi over 3, go to the angle pi over 3 and move 4 rings out. And there's my point. All right, the last one, 0, -5. So we'll find our r value first. 0 squared plus -5 in parentheses squared. Well, that is just 5. So our r is 5. Theta, though, is going to be a little interesting here. We would do tan inverse of -5 over 0. Well, that's not going to be possible for us to do on a calculator because we can't divide by 0. So I'm going to go ahead and graph this so you can see what it looks like. The point 0, -5 would be down here. Well, if I'm going to plot that same point, I know the r is 5. I just don't know the angle. Well, if you think about what angle I would need to be able to get to that point, that would be the angle 3 pi over 2. So if I move 1, 2, 3, 4, 5 rings away at 3 pi over 2, that's going to give me the same point. So this is going to be 5, 3 pi over 2. And actually this does work because the tangent of 3 pi over 2 is undefined. So you actually do still get the same value. We just can't really get an inverse on the calculator doing it that way. So, all right, so that is it for plotting points. Next class, we're going to look at some really crazy graphs using these polar coordinates.